Innovating tree nut harvesting. Hi, I'm Kenzie Maxoutopoulis. I'm currently a student at UC Merced, majoring in computer science engineering. I plan to graduate by spring 2024. The overarching purpose of this project is to feed the growing world with almonds and pistachios. According to the USDA, food demand will increase by 70 to 100% by 2050. During the 2019-2020 season alone, people in the U.S. consumed at least 2.38 pounds of almonds per person. There are existing nut harvest methods, but they can be improved upon. Tree nut harvesting. So this is how it works. Image 1 is an almond trunk shaker. As you can see, the trunk shaker has a clamp at the end. The clamp grabs onto the trunk of the tree and shakes it for a few seconds at a frequency or RPM rotations per minute, and that takes the almonds off the tree. The pistachio tree also has a trunk shaker, but you can't see it because the pistachio tree trunk shaker also has a collector device that collects the pistachios that are falling. Here's a video of a pistachio tree being shaken by a trunk shaker and collecting the pistachios. Current problems with trunk shaking. Right now, it requires an experienced operator. So the people using the trunk shakers right now know how long and how hard to shake each tree to get the best nut removal. Tree damage. So the image on the right is actually an almond tree that sustained damage from an almond trunk shaker during harvesting season. We also aren't yielding the best nut removal. The current harvest amount is about 60% of pistachios per tree. So this can be improved upon to increase food production. The goal of this project is to program a smart harvesting machine for optimal tree nut removal. We want to get the best harvest with reduced tree damage and be able to train a new generation of operators to use the trunk shakers. It's been discovered that the optimal nut removal is equal to 2 times the natural frequency. So that's how hard we want to be able to shake the trees with the trunk shaker. Now, what is natural frequency? Natural frequency is how an object naturally oscillates when a force is applied. So if you have a tree and you hit it and it sways back and forth, that's the natural frequency you're observing. An additional goal we want to use is an easy way to find the natural frequency. So the work I did this summer built upon a previous project from 2022, and I will be discussing that project right now. So in 2022, Dr. Asani and some other ag tech researchers collected data on pistachio trees while they were being shaken with the trunk shakers. So the yellow boxes you can see with the arrows are the accelerometers. So they put accelerometers on the branches of the pistachio trees and then shook the trees for the harvesting and recorded that data. This experiment concluded that as the trunk gets larger, the trees have to be shaken harder to get a better harvest. Now I'm going to discuss the work that I did this summer, building upon last year's work. As I discussed, the 2022 experiment used accelerometers to collect data. This is tedious and time-consuming as the accelerometers have to be individually put onto the branches of the tree. We wanted to find more efficient ways to collect natural frequency data. One of these methods is the laser Doppler interferometer. It works by shining a helium neon laser at a specific point at a tree. It was concluded to be highly effective, but it must be done at the same height each time. Another method that was effective is the motion capture or infrared marker tracking system. It works by putting infrared markers all over the tree then swaying the tree with the natural frequency and recording this movement. It then creates a 3D model. From one of the studies, actually, they were able to find 2 close values to natural frequency. A third effective method is a high-speed camera. High-speed cameras work by recording subtle vibrations and motion that cannot be seen by the naked eye. It measures the same data as accelerometers and is much faster, as you can aim the camera at each tree and find data within seconds. So data analysis for the optimal data-driven model. Prior data from 2022 was collected with acceleration in 3 directions on the X, Y, and Z axes. I created a program in Python to calculate the resultant acceleration for all of the data collected. Resultant acceleration is important for finding natural frequency. So figure 1 is the raw trunk shaking data that was collected. Figure 2 is the trunk data with my acceleration code applied. I had to create the code for this because there were hundreds of files for each sensor, so it couldn't be manually done to calculate the acceleration. Things we wanted to do is help create more experienced operators. So I created a survey to be used in the upcoming 2023 nut harvesting season. We wanted to ask current experienced operators, how do they make decisions when using the trunk shakers? We want to know what kind of factors influence these decisions, such as how long and how hard do they decide to shake the trees? How do they see tree damage? And are their decisions dependent on trunk size? Some of the future work we have for this project is to deploy the survey that I created during the 2023 harvesting season. We can use these survey results to train new operators. Both the survey results and the data analysis with resultant acceleration can be used to help program the data-driven AI model. Thank you for listening to my presentation, and I hope you enjoyed it.